Today we're working on lesson 1, linear functions. Your learning target is, I can interpret the slope and y-intercept of the line of best fit given a word problem and graph. There are many different types of functions. Linear functions, notice that the word line is underlined there, are ones whose graphs form lines, are one of the most important. In this lesson, we will begin to understand how to work with them. So it says, consider the linear function y equals 3/2 x plus 2. Answer the following questions. Now it says, find the average rate of change for each of the following intervals and show your work. Now, average rate of change, I'm just going to type this in. Let's see. We'll do it right in the box. Average rate of change is the same thing as slope. Now, when we calculate slope or the m value, there is a formula for that. So I'm going to insert that formula for you right now. It is a fraction, so we're going to insert that fraction first. And we have subscript, so I'm going to press, it's y, and then a subscript is basically, it is this marker right here. So it's y2, I don't think that worked. Hold on. There it is. So it's a fraction, so we are going to first insert a fraction, and then we're going to have a subscript. So it's y2 minus y1 over x2 minus x1. Now, I'm not writing those as subscripts right now, just because it's kind of a pain in the butt to type it into an equation. So remember, that's the same thing as rise over run. Okay, it's just a little more formal. So for this problem, it wants us to find the average rate of change, or the slope, from x equals 0 to x equals 6. So that means I have two x values. I've got x equals 0 and x equals 6. Now I'm writing coordinates here. Now, I don't know what the y coordinates are yet because they don't give them to me, but that's what I have to use the function for. So up here, I see my function, y equals 3/2 x plus 2. So if I type that equation in, y equals 3/2 is 1.5. I think it's just easier to work with a fraction or decimal in this case. So for the first coordinate, I know x equals 0. So I'm going to plug in 0 for x. You can type all of that in your calculator at once, 1.5 times 0, and then add 2. You should get 2. So that's my y coordinate that goes along with 0. Now we have to do the same thing, except instead of plugging in 0, we have to plug in 6. Again, you can type all of that into your calculator. We should get 11. So that's that y coordinate right there. Okay, now we have to plug it into our formula. So y2 is, so I can't really label these on here. y2 is going to be 11 minus 2 all over x2, which is 6 minus 0. And we'll start simplifying that. 11 minus 2, get my fraction operator here, is 9. 6 minus 0 is 6. And if we simplify that further, so I'm going to keep this as a fraction. Okay, so if you type this into your calculator, it would be 9 divided by 6. Okay, and we should get 1.5. But like I said, whenever we're talking about rate of change or slope, it might be easier to write it as a fraction. I will accept 1.5. Or if you press second, ABC, because I want to look at it as an improper fraction. If you put a mixed number in, it just gets more confusing. So second, oh, I'm sorry, you have to press second PRB first, and then second ABC will give you 3 over 2. So that means my rise is 3. My y values increase by 3 as my x values increase by 2. Okay, or you can also put this over 1, 1.5 over 1. Okay, to make that into a fraction. I'm kind of getting a little ahead of myself right now because I know what's coming, but either one of those would be a correct answer. All right, so I want you to pause the video and try the next one from x equals -4 to x equals 4. Okay, check your work with my work. Now you should get the same answer. Now that kind of seems a little strange, but let's think about that. We're using the same function, y equals 3/2 x plus 2, and it is a linear function, which means it has a constant rate. It means the rate is the same, which means the slope is the same. So if these were different, that means that it would be non-linear. But since they're the same, it just goes ahead and proves that it is linear. All right, so let's take a look at the second exercise. It says a balloon is let go at a height of 4 feet above the ground and rises at a constant rate of 2 feet per second. So again, it is let go at a height of 4 feet. So like imagine that you have a balloon in your hands and you're about to let go of it. Now that balloon is a couple feet off the ground unless you're laying on the ground. Okay? So it's going to rise at a constant rate of 2 feet per second. So before we are letting go of the balloon, so when the time is 0, it's already at 4 feet above the ground. After 1 second, we are now increasing by 2 feet per second. So 4 feet, we're already there, and then 2 feet per second. So now we're at 6. And we go to 8, 10, 12, and 14. Let's graph the data from the table and connect with a line. So we do not have our graph here with us. So there is a graph on the hard copy. However, you cannot graph it on the Google Doc. So just remember, if you graph a linear equation that has the same rise over run or the same slope, it's going to end up being a line. So what are the slope and y-intercept of this line? Slope is the rate of change, how we are changing. That's 2 feet per 1 second, okay? Rise over run. Or if you just write 2, that works as well. Your y-intercept is the starting point when x equals 0. So when t equals 0, it's t in this problem, we are at 4 feet above the ground, okay? All right, equations of linear functions. The equation of all linear functions can be summarized by y equals the rate times x plus the initial value. That's our normal y equals mx plus b. So for each of the following scenarios, identify a rate and an initial value given and write the linear equation that models the scenario. So letter A says Lizzie has $50 in her bank account. She decides to save an additional $15 per week of her allowance. If she doesn't spend any more money, write a linear function for the amount of money she has saved, A, as a function of the number of weeks, W, she has been saving. So our slope or our rate of change is the rate, how it is changing. So if we look in the problem, the $15 is her rate. That's how much she's saving per week. The y-intercept is how much she already has. She already has $50 in her account. So it says write a linear function for the amount she has saved. That's A. So instead of y equals, we're doing A equals. Our m is our slope, 15. Our weeks stands for W. So instead of x, we're going to do W plus the y-intercept. And that's our equation of our linear function. Okay, go ahead and self-assess. If you have any questions, make sure you contact me.